Okay, so the first of our wave questions, and this was talking all about intensity and interference. So we've been told here that we've got A and B both are in phase with the same amplitude, therefore the coherent source with a frequency of 150 hertz. One is already located 2.25 meters, and the other is 224.3 meters, and they are emitting at the speed of sound. He then says deduce, this is like showing, we're using maths, that a minimum intensity is heard at P. So remember, if we're looking for a minimum intensity, we're looking for a destructive interference, so we're looking for them to be anti-phase, so a half lambda path difference or a multiple of a half lambda path difference in there. So at this point, I'm going to look and find out what I know. So I know the path difference is 1.8 meters. I can also then find out what the wavelength is of these. So I can use V is equal to F lambda. Lambda is equal to V over F. So that's 340 over 850, so that's 0.4 meters. So in this case, I'm going to then divide my path difference by my wavelength. So 1.8 divided by 0.4. And that tells me that my path difference is made up of 4.5 waves. Okay, so that path difference in there, how many waves is that equal to? So at this point, you've got to be thinking, well, how many waves is this? Well, if we know the wavelength was 0.4, we divide through, we find that we have 4.5 waves. So since it's in multiples of a half lambda, it is going to be minimum. It's going to basically be destructive. The waves are meeting anti-phase, we get destructive interference. So in here, you got like a mark for deducing this, you've got a mark for showing the wavelength, you then get a mark for showing the multiples of wavelengths, and then your statement kind of confirming why it's destructive in there for your 4 marks for this one. The next one was then asking you to predict the variation of the detected intensity. So now we have at P and we're going to Q. So at this point, you get a mark for saying that there are going to be areas of maxima and minima. Okay, so simply 1 mark for saying that. You also get a mark for saying that Q is a maxima. Okay, essentially at this point, we know that both of these waves are travelling the same distance. So going from here and going from here. I thought that was going to draw on for some reason. That did not. So if we draw, now I can't even draw on properly, but at Q they would meet at the same, so they would be in phase. You could also go a little bit further if you wanted, and you could predict that between P and Q, because remember this was at 4.5 wavelengths. If that's 4.5, remember every full lambda, so we have 0, 1, 2, 3, 4. We're going to have 4 different maxima between that different point. You could also say the same. You could go have 1, 2, 3, 4, 5 different minima going on, or 4 different minima up until I get to the point P as well, if you wanted to say that. The next one wasn't done the greatest, but it is something that we have gone over a few times. Essentially here, we're having to look at the estimate between this, and we're going to be talking, it's asking us to here to find out this relationship, this ratio here. Now, they're not giving me any calculations for I, but I have been told something about loudspeaker B being now disconnected. Well, if B is disconnecting, we only now are getting 1 wave coming through. Before, we were getting 2 waves, and we were getting constructive interference. Okay, because they had the same amplitude, this new amplitude that we were getting was like 2A, and this would just be A, and this one would just be A. If we cancel off the amplitude here, we're only now going to have the amplitude being halved at this point. So for when B is closed, we're just going to get A. All right, I hope that makes sense. So if B is disconnected, the amplitude is halved. Okay, so our IA, we only have half the amplitude. Now that is getting you 1 mark. If you remember that intensity is proportional to the amplitude squared. So essentially what I said here was then, is that if I have I of A, well, A was just 1, it's my original amplitude. I naught, was it doubled? So that's 1 squared over 2 squared, so it's 1 over 4. Okay, this one here is my IA, and this is my I naught, if that makes sense up at the top. So 1 squared compared to 2 squared, 1 over 4, that's the ratio. The next one again was an explanation. It was a wordy question, and I think a lot of people overcomplicated this as well. Okay, mainly just describe the Doppler effect. You actually don't need to describe the full Doppler effect. You're just explaining why it's going to be appearing lower from here. So in this case, we have a moving observer. Okay, we know the loudspeaker is stationary and it's the microphone is moving away. So I shouldn't be talking about anything moving towards something. Now, the microphone moves away, less waves or fewer waves are recorded in the same amount of time. So the frequency is going to decrease. So you get a mark for saying that. Now, the reason for this is as we move away from this, okay, the speed of sound, so the speed of sound, which we know is 340, is moving out. But as the microphone moves away as well, relative to the microphone, this speed will appear slower. Okay, that was the second mark for what you needed to say for this. So something like the speed of sound relative to the microphone is less. Okay, or the speed of sound is relatively less compared to looking from the microphone. Okay, but the speed of sound relative to the microphone is less. Okay, so this microphone, it appears to be slower than it. Okay, than it actually is. It then was asking to calculate V, so in this case it's a moving observer, so we have to do the plus or minus on the top. In this case, because it's moving away from it, it's a negative sign. Okay, remember for moving observers, if we are moving away then we use negative, if we're moving towards we use positive. At this point I plug in my values, so 845 is equal to 850, and then 340 minus U, 340, and then simply rearrange to get U, so U is equal to 340 minus, in my brackets, 340 minus multiplied by 845 over 850, which gave me 2, I should actually write 2.0 because these are all being given to 2 or 3 significant figures, so 2 meters per second is my answer there for the last one. Okay, oops, and we'll do number 4.